Okay, so the first part of today's lesson is review of derivatives of inverses. We did this back in like late November, early December, and I kind of just previewed it to you then, so that again, hopefully this will at least, even if it's new, it's still the second time you learned it, your brain's going to accept it better than the first time. So if you have two functions that are inverses, so let's talk about real quick, what is an inverse? What things are switched? The x and the y get switched. This is true whether you're talking about points, like the point 1, 2 changes in the point 2, 1. It's true of graphs reflected over the line y equals x. It's true of equations. Everything with inverses really comes back to x's and y's are switched. Okay? So if you know that and you're trying to find the derivative of one of those things, you can figure it out using this formula. Today is not the day to worry about memorizing this formula. Today, we are going to use the formula. We're going to figure out when we need to use it and how to use it. Okay, later on, we will worry about remembering it. Okay, that's not for today. So this is kind of a pretty standard problem right here. I'm given some information about g and f, and then I'm asked about g prime of 2. So if I want to know what g prime of, or negative 2 is, okay, and I know that g and f are inverses, then I can just use this formula. So notice with the formula, all I'm going to do is replace the x's, or the x, there's only one, with a negative 2. Okay, so I'm just using the formula. And then this is not f prime times g. It's f prime of g of negative 2. This is function composition, so that means I got to start on the inside, g of negative 2. Now they might, in this case, they come right out and tell you what it is. Sometimes you have to go looking for that information. So if g of negative 2 is 5, then my next step is to figure out, okay, well, what is f prime of 5? And again, they may or may not come right out and tell you that. They do in this case. We will talk about what happens when they don't. So this denominator is negative 1/2. Although it's perfectly fine to write your answer as 1 divided by negative 1/2, what is that simplified? Negative 2. This would most likely be a multiple choice question. And so we're going to work a couple of those. And you're going to see the difficulty raise up just a little bit here. So these are both actual AP test questions that have been on the AB test. So let f be a differentiable function. And they give you all this information about f and f prime. And then they say, okay, we also have a function g that's differentiable. And then they give us that. What are they telling us with this statement? They're inverses. Now, you're already thinking inverses, so that was a little obvious today. But if you saw this problem in a month, how would you know this was talking about inverses? What was your clue? The little negative 1 that looks like an exponent, but it's not because it's being applied to the f. That's inverse. So, and then they want to know, okay, well, what is g prime of 3? So we're going to do the same thing we did before. We're going to use the formula. Now, mine's already off the page. But you're going to look at that formula, and you're going to do 1 divided by f prime of g of 3. Okay, and again, we're going to start on the inside. What is g of 3? They do not come right out and tell us what g of 3 is. They tell us what f of 3 is. Is that close enough? No. I am going to tell you this f of 3 equals 15. This means the exact same thing as g of 15 equals 3. Those two statements are the same because g and f are inverses. So what do you think g of 3 is? 6. So g of 3 equals 6. If you're like, how did they get that? They notice that if f of 6 is 3, g of 3 is 6. You switch the x and y. So I'm going to put a 6 down there. Now we got to find f prime of 6. They're a little nicer to you about this one. I guess they figure you got this far, we'll go ahead and give you the rest. F prime of 6 is -2. So what's the answer? A. So if you know this formula, this problem doesn't really turn out to be that bad at all. So that's why we want to know the formula, because these problems tend to not be that bad. I'm frozen up here. Okay, I know you're not all done, but can anyone tell me what was g of 1? 0. We get that from right here. We just switch those two things around. So that was the easier part of this problem. Okay, do they come right out and tell us what f prime of 0 is? No. However, they give us a function. So can we find f prime of 0? Yeah, first we find just f prime. So we move the 3 down, we keep the inside the same, and subtract 1 from the power. Times, using chain rule, I got to go times the derivative of the inside. So that was just the derivative using chain rule. And since I want to know what f prime of 0 is, now I'm prepared to plug 0 in for x. Because this is multiple choice, we do need to simplify. So what do we get? Yeah, 6. D. Okay. So again, this one had more steps involved, but when you break it down, you guys can do these steps. I know you can. It does start with memorizing the formula. Not today's goal. Today's goal is just to know when to use the formula and how to use the formula. All right. So that was kind of the first mini lesson. All right, let's go to the next page, and here we have another little mini lesson. All right, derivatives of inverse trig functions. Okay, I want to go over something before we even get to the inverse trig part. Whenever you're finding derivatives, what are all the rules that we have for how to find derivatives? Product rule, chain rule, and quotient rule. We have these for when we're deriving. We do not use u substitution when we're deriving. We only use u substitution when we're integrating. Now I get that there's some u's here and it looks like u substitution. But what I'm saying we're not going to do is we're not going to go let u equal this and du equals this and then replace. We don't. That's a little overkill for how to do this problem, and we really only use that strategy with integrals. There's a way to kind of use it with derivatives. I don't do that because that's going to confuse you. I like to keep them separate. Okay, now there are two formulas here. Okay, one for arcsine and one for arctan. Okay, if you're like, why do we have to do this? Here's another thought. We could also be learning arcsecant, arccosine, arccosecant, and arccotangent. But we're not. We're going to use the two that we need to know this year and the two that we would need to know if we were taking calculus beyond this. Okay, so for like the application, it's these two that are used. All right, so this is the only thing. If any of you are going to become math majors and you want to know all the other ones, feel free to your heart's content to look those up. They're very similar formulas. Eventually, you need to know these formulas. For today, that's not our goal. Our goal is to know when to use which formula and how to use the formula. Okay, so first of all, what does this even mean? Arcsine of u. The reason they put a u there is not the exact same as when we do u substitution. It just means we might have something more complicated there. And so we're going to have to apply chain rule. So if you notice this down here, we have u prime on top all right, over the square root of 1 minus u squared. Another way this could have been rewritten is it could have looked like this with times u prime off to the side. These two things are equivalent. Okay, so let's go ahead and do this problem before we even talk about arctan. All right. We don't need to use product or quotient rule here. We are going to be using chain rule. This times u prime, that's chain rule. All right, and so I don't care whether you go times u prime or you put the u prime on the top. Doesn't matter to me. They means the same thing. Either way, you're going to have a fraction. And whether you put a 1 on top, or in this case, what is the derivative of 2x? 2. So you've either got to put the 2 on top or you got to put a 1 on top and then go times 2 at the end. It doesn't matter. Either way is fine. The denominator, I'm just using the formula here. It is going to be the square root of 1 minus. In this case, I'm going to do 2x squared. If you want to rewrite that as 4x squared without parentheses, awesome, do that. You don't have to. And that's the derivative of arc sine of 2x. All right, so with arctan, first of all, let's see if there's another way we could have rewritten this. 1 over 1 plus u squared times u prime. So again, using chain rule. And what are the differences you notice in the formulas? How is arctan different than arc sine? There's no square root, and it's plus instead of minus. This is how, again, not the goal of today, but this is how students in the past have kept these straight. And I've used this strategy when I was in school, learning it for the first time. Arc sine. S for arc sine, what does square root start with? S. What does subtract start with? S. Okay, so that whole theme of arc sine, subtraction, square root, and then over here with arctan, okay, what does a plus look an awful lot like? A T. Okay, so that's a way you can keep them straight. Again, not the goal for today, but I'm just putting it out there. Eventually, yes. I don't even want to talk today about when you need to have them memorized. But I would say in the short term, if I gave you these two formulas and didn't tell you which one was which, I expect you to know which one is which. Which one, like if I blotted out arc sine and arctan, would you know which one went with arc sine and which one went with arctan? In the next couple of days, that's where you should be. Okay, other than that, we got more time. So I'm going to use this formula. We have a fraction. The derivative of 3x goes on the top. I'm going to use the one that's typed here, but you could use this other one. They're equivalent. No square root for arctan and a plus for arctan. And then 3x squared. And again, you can rewrite this as 9x squared with no parentheses. That's perfectly fine. Okay, so that's how you derive arc sine and arctan. So let's apply it to some things. Okay, first of all, with C, I have an x times an arc sine of square root of an x. So what do I need to do? What rule do I need to use? I'm going to definitely be using chain rule on all of these. That's part of the formula. But when you have a function of x times a function of x, we need to use product rule. I know several of you said that. So remember that product rule means derivative of the first thing times the second thing plus for product rule the first thing times. Okay, this is the new part. How do you take derivative of arc sine? It's a fraction. The derivative of square root of x, which by the way we might want to rewrite as x to the 1/2. Yep, 1/2 x to the negative 1/2. And then since it's arc sine, this is what I was saying, the S and sine, that can be a way that you remember the square root and the subtraction. And then here I would have square root of x squared. You could just write that as x. Yes, it'd be equivalent. And that's a simplifying step, and we're going to get to the simplifying. We're just focusing on when to use the formula and how to use it properly. That's our goals for today. Future goals are memorizing the formula and then in the end, simplifying when necessary. Okay. So then we look at D. Do I have to use product rule for D?
No.
Could I use product rule for D? Yes. Why do I not have to, though? 6 is just a number. It's not 6x. It's just 6. So when I take the derivative, I can just do 6 times. And again, this is arc sine. So I need to take the derivative of that, e to the 2x. That's going to go on top. Remember, e is for easy. The derivative of e to something is that exact same thing times the derivative of 2x. This is like a peanut M&M, by the way. You've got 3 different things going on. You just take it one step at a time. On the bottom, this is arc sine. So you have square root, you have 1 minus, and then this thing squared. And that's your answer. I'm going to skip over 3 for now, but I do want to just remind you the general steps of how to do extrema. You find y prime, you figure out when is y prime 0 or undefined, that gives you critical numbers, and then you set up a sign chart, you know, and it looks something like this. Just want to just review that. You're not going to have to do any of these on your assignment tonight, but it's the same thing that we did before, but I really want to spend time on this 4, which is a tangent line. If you haven't noticed, we pretty much do tangent lines in every single unit because it's a repeated theme, and I just don't want y'all to forget because they're actually not that bad. Do y'all like when I say not that bad? But it is. It is going to be okay. All right, find an equation of a tangent line. If someone walked in here and they had just like gone on a trip in December and they just showed up back up today, they would know how to start this problem. Okay, so how do you start this problem? Point and slope. You're lucky if they give you the x and the y. Sometimes they only give you the x. I guess they could only give you the y, but I don't really see that happening. And in this case, they only give us the x, so we've got to do 2 things. We've got to find the y, and then we've got to find the slope, and then we write our line. So one thing at a time. Let's find the y value. So the y value is going to be 2 arc sine of root 3 over 2. No derivative or anything. We're looking for the y value right now.
Instead of using the formula, can you just go back and do the triangle thing?
Yeah, so if you're not quite sure what arc sine of 3/2 is, think about it like this. It's positive, so let's put this in the first quadrant. Let's figure out what the angle is. If you remember nothing about trig, what's that 9-letter thing that we used? SOHCAHTOA. I know some of you are like, what do you mean? But you remember what I'm saying. SOHCAHTOA. So opposite and hypotenuse. If you remember nothing else, you got to remember this. So opposite of the angle is root 3. The hypotenuse is 2. What does that mean the other side is? A 1. And so this is a 30, 60, 90 triangle. So is theta 30 or 60 degrees? How do you know? Yeah, square root of 3 is bigger than 1, and so the bigger angle would be across from root 3. All right, now we need to be in radians in this class. So what is 60 degrees in radians? Pi over 3. Okay, so 2 times pi over 3. Or I'm going to just go ahead and write it as 2 pi over 3. That's my y value. Okay, these little problems right here, 5 through 11 odd, is just practicing arc tan of 1 and so on. And the answers are in the back of the book. I think we need to practice that a little bit. Okay. How are we going to find slope? Derivative. So this is what we just kind of got through going over. How do you derive 2 arc sine x? 2 times. Do you know which formula to use? Okay, whichever formula you use, derivative of x, 1 goes on top. For arc sine, we got the square root, and we've got the subtract. And then this is just x squared because it's just plain x. There's no anything else. All right, that's f prime. Slope, it's going to be the same thing, but instead of x, we're going to plug in that x value. Now, before you throw a hissy fit, let me just remind you that you do not have to simplify this step. You can, but you do not have to. It does turn out to be, the whole slope does turn out to be 4, in case you're just dying to know or want to check your work. You don't have to simplify that though. So my final answer would be y minus 2 pi over 3. And then I'm going to just put that unsimplified slope because this is what I think most of you would do, given the choice. And then x minus root 3 over 2. So that was applying what we just learned to tangent line. Okay, so you have this homework assignment. The first part has to do with inverses. This 5 through 11 odd is just practicing arc inverse trig. All right, and then 41, 47, 51, and 55 is just how to derive arc sine and arc tan problems. Okay, I'm going to strongly suggest you get some of this done before you come in tomorrow. It'll make tomorrow's lesson easier. This, though, is due Wednesday. You got 2 days. That's how all the homework is going to be in this unit. I